All right, programmers, welcome back to another exciting session. My name is Reginald. Today, I'm diving into the fascinating world of C++ control structures. Specifically, we'll be focusing on Chapter 4, Control Structures Y Selection. This chapter is fundamental for anyone looking to master C++. Please hit the like button, leave a comment, and subscribe to the channel. If you are unable to do that, you will need to log in. If you do not have a YouTube account, you can create one free and it takes less than a minute. So what exactly are control structures? In simple terms, they're the way we control the flow of our program. They help us make decisions within our code. Think of them as traffic lights for your code, directing it when to stop, go, or take a detour. Just like traffic lights manage the flow of vehicles, control structures manage the flow of execution in your program. Let's start with the most basic, the if statement. This is the simplest form of decision-making in C++. It's like telling your program, if it's raining, take an umbrella. This is a straightforward condition. Here's how it looks in code CPP. If rain equals sign true. So simple, right? This is the foundation of making decisions in your code. A computer can process a program in one of the following ways. In sequence, selectively, by making a choice, which is also called a branch, repetitively, by executing a statement over and over using a structure called a loop, or by calling a function. The two most common control structures are selection and repetition. In selection, the program executes particular statements depending on some conditions. In repetition, the program repeats particular statements a certain number of times based on some conditions. Logical expression is an expression that evaluates to true or false is called a logical expression. Given the input stream variable sin, the expression sin evaluates to true if the last input succeeded. Relational operators in C++ equals sign equal to called the equality operator. Equal sign not equal to. Equal sign less than or equal to the conditional operator, written as, is a ternary operator. The operator is unary, so it only has one operand. A bank would like to send a notice to a customer if her or his checking account balance falls below the required minimum balance. That is, if the account balance is below the required minimum balance, it should send a notice to the customer, otherwise it should do nothing. The value of the expression in a switch statement must be an integral. Logical operators enable you to combine logical expressions. There are many programming situations in which you must choose between two alternatives. When using a return statement, the return of any value other than 0 indicates that something went wrong during program execution. In short-circuit evaluation, the computer evaluates a logical expression from left to right and stops as soon as the value of the expression is known. Earlier versions of C++ did not provide built-in data types that had logical or Boolean values, true and false. Because logical expressions evaluate to either 1 or 0, the value of a logical expression was stored in a variable of the data type int. Therefore, you can use the int data type to manipulate logical Boolean expressions. Break, default, and case are reserved words in C++ to permit more than one statement to execute if an expression evaluates to true. C++ provides a structure called a compound statement. You can use either a int variable or a bool variable to store the value of a logical expression. When C++ evaluates a logical expression, any non-zero value is treated as true. There you have it, control structures. When we return, we will discuss relational operators and string type. The relational operators can be applied to variables of type string. Variables of type string are compared character by character, starting with the first character and using the ASCII collating sequence. The character-by-character comparison continues until either a mismatch is found or the last characters have been compared and are equal. The if and if. Else structures control only one statement at a time. Suppose, however, that you want to execute more than one statement if the expression in an if or else statement evaluates to true. To permit more complex statements, C++ provides a structure called a compound statement or a block of statements, short-circuit evaluation of a logical expression. A process in which the computer evaluates a logical expression from left to right and stops as soon as the final value of the expression is known. The programs that you have written until now should have illustrated that a small error, such as the omission of a semicolon at the end of a variable declaration or using a variable without properly declaring it, can prevent a program from successfully compiling. Similarly, using a variable without properly initializing it can prevent a program from running correctly. Recall that the condition associated with an if statement must be enclosed in parentheses. Recall that if the decision-making expression in the if structure evaluates to true, the statement part of the if structure executes. In addition, the expression is usually a logical expression. However, C++ allows you to use any expression that can be evaluated to either true or false as an expression in the if structure. Cool as a cucumber. Certain if, else statements can be written in a more concise way by using C++'s conditional operator. Here's a snippet. The conditional operator, written as, is a ternary operator, which means that it takes 3 arguments. Next up, the switch statement, pseudocode and flowcharts. There are several ways to develop a program. One method involves using an informal mixture of C++ and ordinary language called pseudocode, or just pseudo. Sometimes pseudo provides a useful means to outline and refine a program before putting it into formal C++ code. When you're constructing programs that involve complex nested control structures, pseudo can help you quickly develop the correct structure of the program and avoid making common errors. All right, that was a mouthful. Let's take a quick break. When we return, we will dive into switch procedures. There are 2 selection or branch structures in C++. The first selection structure, which is implemented with if and if, else statements, usually requires the evaluation of a logical expression. The second selection structure, which does not require the evaluation of a logical expression, is called the switch structure. C++ switch structure gives the computer the power to choose from among many alternatives. If the possible range of values for a multiple selection statement cannot be reduced to a finite set of values, you must use the if-else structure. In C++, switch, case, break, and default are reserved words. In a switch structure, first the expression is evaluated. The value of the expression is then used to choose and perform the actions specified in the statements that follow the reserved word case. Recall that in a syntax, shading indicates an optional part of the definition. A break statement causes an immediate exit from the switch structure. Although it need not be, the expression is usually an identifier. Whether it is an identifier or an expression, the value can be only integral. The expression is sometimes called the selector. Its value determines which statement is selected for execution. A particular case value should appear only once. One or more statements may follow a case label, so you do not need to use braces to turn multiple statements into a single compound statement. The break statement may or may not appear after each statement. The general diagram to show the syntax of the switch statement is not straightforward because, following a case label, a statement and/or a break statement may or may not appear. How about that? We will look at the next topic right after this short break. Certain types of errors that are very difficult to catch can occur in a program. For example, division by 0 can be difficult to catch using any of the programming techniques you've examined so far. C++ includes a predefined function, assert, that is useful in stopping program execution when certain elusive errors occur. In the case of division by 0, you can use the assert function to ensure that a program terminates with an appropriate error message indicating the type of error and the program location where the error occurred. You can disable assert statements by using the preprocessor directive #define_n_debug. The specification of the assert function is found in the header file cassert. Thanks for joining me on this adventure. If you find this video useful, please hit the like button, leave a comment, and subscribe to the channel. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Now you are ready for the programming exercises for Chapter 4. I will see you there.